Hey math kids, today we're going to talk about differentiation from first principles. So if you remember our previous video about the gradient of a tangent line, we're going to look at that. So derivative of f of x at a is the limit as h approaches 0, f of a plus h minus f of a. If you want an explanation on where this comes from, make sure you watch that previous video. I think it was 2 videos before this one. Okay, so this is the gradient to the tangent, and y is f of x at x equals a, and then we say that f of x is differentiable at x equals a. Now, the derivative function is this. It looks very similar. Okay, we're going to use these on this next one. Okay, so there is a shortcut to find the derivative on this, but the whole point of this is to do it from first principles. The power of first principles, if you understand it, is that we can do the derivative of anything using this first principles method, but most of the time in this class, we're going to go to shortcuts, and we'll learn little shortcuts for every little function that we come across. So you may already be aware of a shortcut, but it is important to practice this because some derivatives, this is the only way we can find them. Okay. All right. So it just wants us to find, using first principles, this. So if we write the limit as x approaches, or h approaches 0, f of x plus h minus f of x all over h. So our function is x to the fourth, and so if we replace x with x plus h, we're going to get x plus h to the fourth. This is just f of x, so it's just x to the fourth. And h is just going to stay h. Okay, so with limits, we try to plug in a 0 for h, but that creates division by 0, so that's not good. So we need to somehow cancel that h that's on the bottom. So what we're going to do is we're going to do an expansion. Where I'm going to use Pascal's triangle. So we have the limit as h approaches 0, and then I have x to the fourth. Well, here, 1, 4, 6, 4, 1, minus x to the fourth right here. X to the third, x to the second, x. Then we have h to the fourth, h to the third, h squared, h, no h, and then h is down there. Okay, so this is going to cancel this. All the remaining ones have an h, so one h will go away from each of those to cancel this bottom one. So that h goes away completely. The squared goes away there. This goes away, becomes squared. This goes away, becomes cubed. So we're left with the limit as h approaches 0 of 4x cubed plus 6x squared h plus 4x h squared plus h cubed. Now there's no division by 0, so we can plug in the 0. If we plug in the 0 here, here, and here, it all cancels, and we're left with 4x cubed. So that is the derivative function. So f prime of x equals 4x cubed when f of x was equal to x to the fourth. Okay, now it wants us to find f prime of negative 1. So f prime of negative 1. So all that means is take this derivative function, plug in negative 1 for the x. So we get 4 times negative 1 cubed. Negative 1 cubed is negative 1. Negative 1 times 4 is negative 4. So that would be the gradient of the tangent line at the point x equals negative 1.